Hey everyone, this video is going to cover hot water recirculation systems and how to balance them. At the end of the video, I'm going to use a use case that will basically solve the issue on this system together. Right, so if we get started, we'll go and we'll model out a simple hot water recirculation system. To start off, we need to have a residual and static pressure and height above floor with a flow source. We'll draw that into the back of a hot water plant like that, and then we'll start to draw our hot water recirculation from there. Now, you may already know that to do a hot water recirculation sizing system, you need to have a balancing valve on that return pipe. The reason for this is when you have multiple branches, this is how h2x selects the index circuit for the pump sizing on the hot water plant. Now, there are a few rules that you need to obey with this in order for h2x to be able to do those calculations. One of them are that for every branch, you need to have a balancing valve on each of those individual branches. So we've got two branches on this, meaning that we need two balancing valves on that return. You don't need an additional one here, and having one there will actually cause h2x to not be able to do the recirculation calculations. If you need to have another valve on there to represent another piece of equipment or even a balancing valve that you want to place on a natural system, put a custom valve down, name it, and give it a fixed pressure drop or a K value pressure drop for it to be associated on that index circuit calculation. Now, this is branching off on a horizontal level. You can also branch off on a vertical level. So let's say we had two risers here and here. This would then become its own branch. So what we would need to do on the level that we connect on, we would need to have a balancing valve off that branch. Like that. Now, again, if you branched off on this level, you would need to make sure that you have two balancing valves. However, they would need to be upstream of that split or downstream of that split, essentially on the other side of this one that it currently is on. So balancing valve here and here, and then you wouldn't need the one here. The other rule is that for every fixture or every load node that you apply, the balancing valve must be downstream of it, meaning that it can't be on this side of the arrow. So essentially, the arrow is pointing away from the balancing valve. You can't have fixtures connected to this or the orange pipe work once you hit results. So you can have fixtures here. That would be fine. However, if you were to add a fixture here, that would not be fine. You would receive a warning. I've hit results there. Fixture cannot be connected downstream of the balancing valve. So moving our example system aside, we're going to take a look at a case study that has been taken from a live project. I've deleted all of the PDFs, so I've only taken a portion of the system, deleted some levels on there just to show how to fix this particular scenario. So if we hit results, we are getting some errors saying that we're missing balancing valves. For now, I wouldn't recommend just hitting fix it because sometimes h2x might place a balancing valve in the wrong place. But if we assess this system back in design mode, you can see that we've got our hot water plant coming over and across, and you can see that we've actually split off to a branch that goes up some risers. Balancing valves here, which would be fine if there wasn't a balancing valve further on down the system. So if we go up here, goes through another couple of risers up to level 6, where we go up to this level, and then we have a split. So each side of that split would need a balancing valve, and we've also got a balancing valve on this level, meaning that we need to go back to the basement and delete this one here. If we go back up to level 6, we'll take a look at our layout here. Looks like we've got a riser where we've got the flow, one recirculation branch that wraps around this way, serves all of these fixtures, which is fine. That balancing valve can be placed there because it's downstream of all the connected fixtures. That's all good. Now we need to take a look at this layout here because you can see there isn't necessarily a clean split between the flow and the return on this. So you can see that the flow, got the connecting fixture there, coming round, connecting to that basin, and then coming back up. So in essence, all we need to do here is add your balancing valve on that return. And then we have pretty much a well-connected system there. If it was the case, and I think it was the case prior to me recording this video, that this was to be connected into there, then that would cause issues. This system wouldn't be able to calculate because you have the flow, and then you have a flow and return coming back onto the same, essentially connected pipe. This must be connected back to the recirculation pipe. Now if I hit results, we don't have any warnings apart from maximum pressure not being acquired and connecting fixtures to flow systems. I hope that's cleared up any confusion on the hot water recirculation modeling in H2X. And if you have any questions or you have any feedback on this video, please feel free to comment below.